Hello, I'm going to explain you how to answer some of the problems you sent me to a few days ago. The first one is how many kilojoules are in 95 calorie? Um, First thing to do, you need to find the conversion between calorie and kilojoule, and I have 1 calorie will have 4.18 joule, right? So if you have 95 calorie, then you need to, I need to close this one. I don't need this. Let me rewrite that again. So if you have 95 calorie, you need to find, that will be your question mark here. You need to find how many joules are. So solving for the question mark, that will be 4.18 joules times 95, and that will be the 95 calorie over calorie, 1 calorie. And then you cancel these two and do the multiplication. Let me bring my calculator to the front. So that will be 4.18 times and 95. And that will be 3. The correct answer should be 397. Let me recheck, double check that I got the right answer. 397.1 joule. But the thing is, they ask you for kilojoules. So for 1 kilojoule equal 1000 joule. So you had 397.1 joule. Then you need to find how many kilojoule will be. So that will be your X will be equal to cross multiplication. You cross this 1 kilojoule times 397.1 joule over 1000 joule. And then you cancel joule and joule, and the answer will be 0.3971 kilojoule. That will be the correct answer for this one. So the correct answer should be 0.03971 kilojoule. The next question you sent was, in what order, what is the freezing point, room temperature, and boiling point of water to the Celsius scale? So the freezing point of water will be 0 Celsius degree. The room temperature of water will be 25 Celsius degree, around that. And the boiling point of water will be 100 Celsius degree. So now in what when you went to Google for better explanation, it gave you the range of 2025. I will select 25. It's more common to have the room temperature at that value. So the answer will be 09500. So that's the correct answer, the one that you selected. Let's go over the other question that you asked me on the email you sent to me. And I have somewhere written here. Let me open this one. They say on the next question, a 15.0 gram lead ball at 25 Celsius was heating with 40.5 joule of heat, giving the specific heat of the lead 1.128 joule gram over Celsius. What is the final temperature of the lead? So the question that you need to use will be this one. Q, which is equal to the heat, will be equal mass, heat capacity, and delta T. What is the delta T? Let me write on the side here. Delta T will be final temperature minus initial temperature. So here is they gave you the mass, 15 gram. They gave you the specific heat or heat capacity. That will be 1.128 joule over grand Celsius. And what is giving? They gave you the heat they gave 40.5 joule of heat, so that will be 40.5 joule of heat. And they ask you first, what is the final temperature? You need to solve this one, but in order to find the final temperature, you need to find delta T because the initial temperature is given here. So they gave you the initial temperature 25 Celsius degree. So if you find delta T, then the final temperature can be solved. So how can you solve for delta T? Let me make on the right here. Delta T, which is the difference in temperature, will be equal to 40.5 joule over 15 gram, and then divide by or multiply by 1.128 gram joule divide gram Celsius. Joule and joule cancel out, gram and gram cancel out, so the unit will be Celsius degree. So that will give you the value of delta T. Let me get my calculator again, and then I will do 40.5 divide 15, and I go 2.7, and then I need to divide again by 1.128, and that will give me delta T will be equal to 2 point, let me go back because I want to double check, 2.39 or 2.3 because we had 3, 2, and yeah, that will be two significant figures, so it will be 2.3 only, and that will be Celsius degree. How can I solve now? So that I had 2.3 Celsius degree here, that will be delta T, final temperature minus 25 Celsius degree. Final temperature will be 2.3 Celsius degree plus the negative 20, I mean, subtracting negative 25 go as adding 25 Celsius, 25 Celsius degree. And if I do my calculation right, and we don't have decimal point here, so the answer should not be having any decimal point. Using my rule, that will be 27, and that will be the final temperature that they're asking you on this equation. Again, this is the formula, and that will be the answer for that. The next one, what is the specific heat of a metal object whose temperature increased from 3 to when 17.5 grams of the metal was heated? Again, it's the same formula. Q equal mass, heat capacity, delta T. And they asking you now to find the specific heat capacity. The the temperature increase in 3 Celsius, so that will be delta T because they go from one to another value, so that will be delta T. The mass will be 75.5 gram, and the heat was 38.5 joule. You need to solve for C. That will be how? C will be equal 38.5 joule over 70.5 gram over 3 Celsius. And then solving for that, that will be the answer. On the next one, the same equation. Q equal mass, heat capacity or a specific heat time delta T. They gave you the heat 49.5 joule, and they gave you the mass 7.3 gram, and at 22 Celsius, when the temperature increased to 37, what is the specific heat of the iron? So you need to solve for C, and you need to find delta T. How can you find delta T? Delta T will be final temperature minus initial temperature. The final temperature is 37 Celsius, 37 Celsius degree, minus the initial temperature 22 Celsius degree. By subtracting that, that will be a 5 and a 1. That will be delta T. So you need to, the equation will be 7.3 C is the unknown, is the one that you need to find, and then 15 Celsius, and here we have the heat. So eventually it's the same formula. I'm going to write here Q, which is the heat, mass, time, specific heat or heat capacity, time, delta T, different in temperature. That's the formula you need to use for solving all the remaining problem. Okay, that hopefully that will help you to continue working on the quiz for chapter 3. Thank you for watching.